and begin. So I invented a shrink wrapping algorithm using the new simulation node setup, and it is surprisingly simple and effective. So here we have 3 monkeys, and I'm shrink wrapping them. It works with any number of objects, and it works like a pressure simulation for cloth, except it's in geometry nodes. And again, using the new loop simulation node. So let me talk about how to do it. It's an idea that you can also use for retopology and stuff like this. So what I'm going to do is in a new Blender scene, make sure you have 3.5. I'm going to add a monkey, and we're going to start by shrink wrapping a monkey, and then we're going to get more and more complicated. So in geometry nodes, I'm going to make a new geonodes group, and the idea is I'm going to cast a big sphere around here, and every frame I'm going to have it come closer and closer and closer to the monkey, and each time detect what close means. And it's this redetection and retopology that we're going to do that's going to make it work. So using the new simulation nodes, I'm going to use a simulation input, a simulation output. We don't actually want the original geometry. What we want is a big sphere around it. And you're like, why are you adding a cube? Because I want a evenly dispersed cube in a sense. So I can subdivision surface a cube. And you can see as we increase the resolution, it turns into a sphere. So we have a big sphere. Let me make it even bigger. A big sphere that is going to be around our monkey with lots of topology, okay? Lots of geometry. And for each frame inside the simulation window, what I wanted to do is come closer and closer to the geometry. To do this, I can use a geometry proximity node. So we're going to say, what geometry are we looking at? This one. And I want to say set the position of our points. Again, this is referring to our big cuboid, I think is the word for it. Here you can see our cuboid. We're referring to that. We want it to come closer and closer to the thing. Now, if we do it automatically, we're going to get like this choppy result, right? It's just going right there. So we have to do it slowly over time, right? If we just cast it, it looks like this. So what I'm going to do is I'm going to mix this using a vector. I'm going to mix this with the original position. So instead of going all the way, let's see what happens if we go halfway. Oh, totally not doing anything. Let's see why it's not doing anything, because it's not connected. So now when we play this, you can see it's doing a bit better, but again, we run out of geometry, like it's being stretched thin. But we are kind of going in, steps. But you can see the geometry is getting clumped together. To fix this, I need to kind of recast the geometry. And I'm going to use a dual mesh node for this, which redistributes the points. It turns every face into a point. And now, you can see this algorithm works. It's not going to be perfect, not yet. But you can see this algorithm works a bit better. It's actually kind of approximating our thing until it goes crazy and the ears get chopped off. And then the whole thing shrinks. So one thing we can do is we can add more geometry to our initial conditions. You can see the more geometry we add, I'm going to go to 6 divisions, the better the shrink wrap's going to be. In fact, this is actually a way to retopologize something using quads. But you can see a lot of my geometry is getting smushed into these creases, high crease areas. What we can do about that is you could do something sophisticated with edge angle, or we could just merge by distance anything that is within 0.01 meters. So let's see what this looks like. Well, this is a cool cloth ripping effect. You want to make sure this merge by distance is set to connected, so it's not trying to merge with pieces that are not connected, which still creates the issue, but just not as bad. We can fix this by dividing this so it's a bit finer. It is a cool effect. And also adding more geometry. I think we could set this to points, adding more geometry to our casting, the thing we're casting to. Well, seems like it's ripping no matter what. Maybe one solution is instead of jumping halfway each time, we have a jump like 10%, so it's 90% the same position. So it's going to take a slower time to calculate, but it's going to be somewhat more stable. Let's set this to faces. And let's set the merge by distance to be like 0.001, so it's not doing it all the time. And there we go. We get a more stable result. And again, this is a retopology of our thing. Now, the cool thing about this is, whatever, you can retopologize, and we can use the shrink wrap modifier. But what this method allows you to do, I'm just going to make this a bit bigger, What this method allows you to do is to add in multiple meshes, and it's going to find what I'm going to call the minimal surface, the shrink wrap, in other words, between these. You can see how it's kind of like dipping in the middle and it's creasing where it's supposed to crease. This is almost like a mathematically precise way to find, again, the minimal surface that minimizes surface area between these. Because if it wasn't, it'd be able to go further inwards. Let's make another thing. Make one of these bigger and see how it handles this scenario. And there we go. You can see it's shrink wrapping every mesh. I believe we can also animate this over time, right? Like we can have the objects moving, but it might be weird. Let's try it. I haven't tried this myself, so this is an experiment. I'm going to add in a UV sphere, and for what we're projecting to, all we have to do in theory is join this into our geometry. So I'm going to join geometry. We don't need a subdivider sphere. And let's bring in our sphere. And I don't know if it's supposed to be set to original or relative, but we'll find out. So is it even respecting the sphere? No, because we haven't selected it, dummy. Okay. Is it? Maybe we set it to relative? There we go. We have to set it to relative. So now it's respecting the sphere. And if I now select the sphere, we can animate this over time, and it's going to try to shrink wrap to it. At least I think it will. If we move it too quickly, it's not going to catch it. But you can see how this almost looks like a cloth simulation, how it's kind of deforming the cloth in a sense. Let me get a bit closer. You can see how it's deforming the cloth in a way. Either way, this is the beginning of how to make a cloth simulation in geometry nodes. It's only a couple of nodes and a continuous ray casting. One last detail to make this more accurate, instead of 0.9, have it only set it to 0.95 and have it go only 5% of the way there. The slower this goes, the more accurate our shrink wrap is going to be. And you can see we get these hard faces that the monkey has. And by increasing the geometry, we'll get an even more accurate result that takes a bit longer to compute. But this is how we get that nice sharpness that we want. So yeah, shrink wrapping and Blender. There you go.